Hi, I'm Wesley Lamberson from Chemistry 116, UAB. This is for Chem Lab, Intermolecular Forces. Um, Here's my experiment. So today I did the experiment with oil and water, and I'm going to be explaining the intermolecular forces that make them not mix when combined. So for this experiment, you're going to need water. So any water will do. Doesn't have to be purified or distilled or anything. You can use tap water. And you'll need a food coloring of some sort. I chose royal blue because it shows up best against yellow in my opinion, but it can be any color, any kind, as long as it dissolves in water. And then for this, I chose cooking oil because it's what I have available, so that's what I chose. So in this experiment, you're going to take your water and your food coloring, you're going to combine them to where you get the colored water. You're going to take your funnel, you're going to open up whatever clear vessel you're going to use to do your experiment so you can watch it. That's the fun part. Put it on top, pour your water in until you get about halfway up. I did a little more than halfway because I have more water than oil. And then you're going to do the same thing with your oil. Pour it in to the level that you want until it looks something like this. And so right now what you're seeing is the oil sit on top of the water. And so what you can do is you can put your lid on your bottle, you can shake it up like this. You see they're all kind of, together. And as you keep waiting and watching, you'll see that the oil will come back to the top. And so the reason of this is oil is nonpolar, so water is polar. So when oil and water are mixed, the dipole-dipole interactions are interrupted, and the constant molecular motion allows stronger dipole-dipole attractions to remove the polar particles from the mixture, so water and oil will separate. So cooking oil does have induced dipole forces, the molecules, which would make it weaker than water, but the molecules are so large and so much larger than water that their strength is greater. And so, oil will have a higher boiling point than water, and because its forces are stronger. And so basically the hydrogen bonds within the water, so H2O, and the London dispersion forces within the oil cause them not to mix. So one is nonpolar, one is polar, and their forces will not allow them to mix. So you can shake it up all you want. You shake it till it looks like this, and they will separate because of the difference in polarity and the difference in their intermolecular forces. And that's video number 1.